Okay, so this is just a review because we're going to use it. So best subset selection fits all p-choose case models. Among the p-choose case models, it finds the best one which has the smallest residual sum of squares, and then it will, among all those, it compares the best which has a um, either using CP, which is AIC, BIC, or adjusted R square. Forward stepwise adds the variables one by one, and backward stepwise removes them one by one, and choosing the optimal model, meaning the model with the right number of predictors, is done either by cross-validation error or proxies for the test error, which is adjusted training error, CP, AIC, BIC, or adjusted R square. And these various proxies are CP, which is proportional to residual sum of square plus a penalty, where D is the number of predictors. And then we have BIC, AIC, which is again residual sum of squares plus 2D sigma square. And BIC, instead of 2, we have log n D sigma square. And we have adjusted R square, and estimating the variance itself is tricky. If we want to use maximum likelihood, we just take the residual sum of squares divided by how many observations we have. And if we want to get an unbiased estimate, we just take the residual sum of squares and divide them by n minus d. Okay, so we do the regular fit with 4 variables because it takes forever, and then we do backward selection, and we start with 60 variables, and then we plot some summary statistics here. So this is backward actually, and if we look at it, we see the CP or AIC is pretty meaningless. And we want a small AIC, and then it picks just one variable, which doesn't make any sense. The adjusted R square is more reasonable, it's at the end of the spectrum. And then we have BIC, which is also at the end of the spectrum. So it makes me think that maybe I need more variables, but 70 is a lot. It's close to the maximum number of variables we have. And we have here, we have forward. Forward performs a little bit better in the sense that, and the IC still is meaningless, but it picks 50 variables, around 50 variables, which is still a lot. Okay, and my guess is that in when you have this many variables and so little observations, the estimate of the variance is unreliable. So we need to use cross validation for model selection. And here, let's look at the estimated coefficients. So if we look at the best model with 3 variables, best subset selection chooses these 3 variables. Backward selection chooses these 3 variables. You see there is nothing nothing similar, and then forward selection chooses these variables. So let's go through all of them. Marine is negative, prop contact diff is negative, prop diabetes is positive. So what are they? So number of alters that make it difficult to be healthy. So the larger this is, this is negative, and what it means is that, just goes this, prop contact diff is negative, and it is counterintuitive. Essentially, it's saying that the H B1AC reduces if the number of alters that make it difficult to be healthy increases, and an increase in H1 is proportional to an increase in the number in the amount of sugar in blood. So we would think it's the other way around, but maybe this is subjective, right? Number of alters. Maybe those who think that they have a lot of people around them who makes difficult to be healthy, they are more aware and they do a lot of other things just to counter that. And because of that, because they are aware, then the sugar in their blood is less. And we have prop diabetes. So, and if you live with people who have been diagnosed with diabetes, that increases also the chances of increasing the H1ABC. So anyway, this is just 3 variables. Let's see what forward says. Education category. So the more educated you are, the lower the blood sugar. And then we had backwards. General health 10. Poor, fair, or good, excellent. And it's negative, so if you're good, blood sugar less. What is neighborhood 4? There's a high crime rate in this neighborhood, so and it's treated as a categorical. And then we have agree. So those who agree, these 24, these 29, compared to the baseline, which is strongly disagree, they tend to have a higher amount of sugar in their blood. But that doesn't apply to strongly agree or even neutral or disagree. So this is strange. Needs to be discussed. Acculturative stress, 8. Actual. Do you think you will be deported if you go to a social or government agency, and those who say yes compared to those who say no have less blood sugar? So the results point in all over the place, but this is where we start, and these are the things we have to investigate. But this is how you look at them and how you interpret them, and they are not consistent, probably because 3 variables are not enough to explain this data. Now the next thing we can do is we can use the stepper function that we introduced in another lecture. Okay, so just to go back from the beginning, we have the data, we remove the missing values, we remove some because of redundancy imbalance, we put all the terms that remain here, we pay attention to the categorical variables, we do a full linear model fit, we get nothing because there are more predictors than observations. We do best subset selections. We don't go larger than 4. You can try 5 and 6. It will take forever. Not forever, but a long time. But even for 4, we can look at the best 4 variable models. Then we do backward selection with up to 65 variables. We look at the residual sum of squares, the CP, okay, the BIC, and then we do forward, and then we look at the residual sum of squares, adjusted R-square, and CPIC, BIC, and then we compare the coefficients. What we see here is so we want the model with the largest adjusted R-square, smallest BIC, smallest AIC. The fact that the AIC here is so small in the beginning and it becomes larger is surprising. This looks more reasonable. Something goes up and then goes down, and it's around 60. And here we have the BIC, which goes down. Again, we don't see the shapes we like to see. For adjusted R-square, we want it to go up and down, and then pick the max. And for AIC and BIC, we want it to go down and up. And we don't see it, so I don't really trust any of these results. So that's, in general, I don't rely much on AIC and BIC, and more on cross validation. But AIC and BIC have also their applications. But in this case, at least, we don't get something meaningful when we apply to the backward. But maybe the forward is going to be better. Now here, as we increase the number of variables, the residual sum of squares drops. Here is the knee. So I would think that the reasonable number of variables should be around 20, but adjusted R-square goes up and down. This is more like what we expect to see, and it goes up, and here's the maximum, so around 50 variables. Yes, and then for AIC, it's still just increasing, which is strange, but BIC is more reasonable now, and maybe this just, yeah, I don't know what's wrong with AIC here, but this is reasonable. So these two numbers at least are close, and the shape is what we expect to see. And then here we can compare the best 3 variable models for each. Now we use the stepper function, which we introduced last week or the week before. And in order to use the stepper function cannot work with categorical variables. Therefore, we take the design matrix, which is not categorical anymore. The design matrix is so it has these features, which is a one-hot coding feature. So church 2, 3, 4, 5, 6, 7, and all of them are 0. That means that the category of church for the first row is 1. We talked about this before. So this is all numerical now. We create a new data set. Now what we have here is as factor in parentheses as the name of the variable, and this stepper function does not cannot deal with it, so we have to change the names here. That's why we change the names as factor instead of the parentheses here. We put these. So that's why we have these as factor now in this form. And here you can see. So this is the full forward model, right? And at the end of this process, these are the p-values for each of the variables. And we said that from when you're at the end of the back forward process, remove any variable which has a p-value greater than 0.5. This has greater than 0.5. This has greater than 0.5. And these two are the largest ones. So I think in the next step, this will be removed. And prop act with is not here anymore. Prop act with is not here anymore. And now this is the largest one, so the next step, marine, should be removed because it's also greater than 0.1. And then at this step, there is nothing greater than 0.1, and we just end here and end of the story. And 16 variable. And 16 variable is more reasonable to me given this residual sum of squares. So this is 10, this is 20, so it's around here as opposed to here. I think here we're taking too many variables because adding variables from 30 to 50 doesn't reduce the residual sum of squares significantly to justify their addition. And that's why I'm skeptical about adjusted R squared BIC, and that's why I think in general, I mean, I'm not saying everywhere, in general, cross-validation is more reliable, especially when we are in such a scenario where P is greater than N, when P greater than. Okay, and so the next lecture will be about how to do cross-validation, how to do variable selection, how to do regularized estimation, such as lasso and ridge. And this one was just to show you how to do backward forward with R and with the data set we have, and how to plot the results and how to look at the coefficients. And yes, so basically a lot of just practical stuff. Sorry. Now let's run this with 5. I'm curious to see how long it will take. So you see, even you just using 5 variables, 5 out of 127 is just to check the best combination is just taking forever. Okay, so I will stop here, and next week we will see how to get over all these problems we had with AIC, with best subset selection, and we will learn how to get over them. And I can't even terminate. That's the problem.